Dear student, today I am going to teach some important property of the group theory. First, I explain about what is the group, then normal subgroup, then cyclic group, then some question related to the university examination, and also prove some property of the lattice. Now, what is a group? Now, group is a mathematical structure consisting a set of the binary operation. Now, here is a binary operation, this one and that satisfy the four fundamental property. It means a group is an algebraic structure or a mathematical structure which follow the given the four fundamental property on the binary operation. Then that algebraic structure or mathematical structure is known as the group. The first property is known as the closure property. Now, what is the closure property? Closure property means if we operate for every true element, operation is multiply and plus, then the result is also belong into the same set. Then we can say that mathematical structure follow the closure property. For example, set of natural number. Set of natural number means 1, 2 up to infinity. In this mathematical structure, for every two element, we perform the multiplication operation and the plus operation. If the multiplication of the two number and addition of the two number is also belong into the same set, then we can say that mathematical structure follow the closure property. It means for every a b such that a into b is also the element of n and a plus b is also the element of n, then we can say that mathematical structure follow the closure property. Now, second property is associative law. Now, associative law is the testing of the next level testing of the closure property. In closure property, actually we check for every two element and the result of the two element using the binary operation is also belong into the same set, then we can say that it is a closure property is satisfied. When in the associative law, then for every three element we operate the binary operation, if the result is also belong into the same set, then we can say that associative law is also satisfied for the group. It means for every a, b, c and we operate the two operation, multiplication and the plus operation. It means a plus b plus c is equal to a plus b plus c, and a plus b plus c is also the belong to the natural number, then we can say that set of natural number is a mathematical structure follow the associative law. It means set of natural number is also follow the association rule. Now, the third one is most important property of a group. Third one is a most important property, that is known as the identity law. Now, what is the identity law? That is very simple. Identity law if we operate an element with identity, then it means any operation with identity, the result is same, then that element is known as the identity operation. Left operation or right operation is equal to A, then we can say that E is an identity element and E is also belong into the same set. Then we can say that that mathematical structure or that algebraic structure is known as the follow the property of the identity element. For example, set of the natural number for the multiplication operation, 1 is identity element, because for every element A multiply by A, we always get A. Then what is the identity for this mathematical structure in the set of the natural number is always 1. It means for the multiplication operation, identity element is followed. For the plus operation, for every A plus 0 is equal to A. It means for the plus operation, 0 is an identity element. Then and 0 is a not element of the natural number. So that for the plus operation, set of natural number is a not a follow the property of the identity element. Okay, that's clear. If we change the mathematical structure, we take the set of real number. Now set of real number, that is minus infinity to 0 and plus infinity. Then set of real number 0 and 1 both are the set of the real number. Then both 0 and 1 is the element of the that mathematical structure. So that for the mathematical operation, for the binary operation, multiplication, for the plus operation, both operation identity element are exist. So that set of real number for the identity element, this property is also followed. Now the fourth one is the inverse property. Inverse property, that is very simple. Now A into B, if we find the identity element, then we can say that B is a inverse of A. A inverse we can write, that is B, if this condition are satisfied. Now first we check the set of natural number, then we check the set of rational number. We taking the two mathematical structure and check whether the inverse property is followed or not. Now for every element we taking 3, then 1 by 3 is equal to 1, and 1 by 3 is not the element of the natural number. It means mathematical structure set of natural number inverse property is also fail, because 1 by 3 is not element of the natural number. When we change the mathematical structure, set of rational number or a set of real number, then 1 by 3, 3 and 1 by 3 and 1 by 3 is also element of the rational number. So that this mathematical structure contain the property of the inverse element. It means set of real number, set of rational number, set of integer, and another mathematical structure, sum operation, that is the modulus operation, is also known as the property of the inverse property. Now this is the some basic property of the group. Now we move over the very famous property of the normal subgroup. Prove that GH G inverse, that is the H. This property asked many times in the university examination. So first we check what is the subgroup and normal subgroup. Then we prove the GH G inverse is equal to H. Now what is the subgroup? That is very simple definition of the subgroup. Let G comma star is a group and H is a subset of G. H is a subset of G if H is also a group, and the property of group we already discussed. Then we can say that H is subgroup of G. Now that is the very simple definition of the subgroup. H is a subgroup. G is a group and H is a subset of G. If H is also follow the property of the group, then we can say that H is a subgroup of G. Now subgroup, what is the normal subgroup? Now if any element we operate H and any element left operate and right operate, if these two are equal, then that subgroup is known as normal subgroup. Now that property, these two definition we discuss, subgroup and normal subgroup. For the normal subgroup, this property is followed. Now we move on this given theorem. How can we prove this theorem? We take a Cayley table. With the help of Cayley table, we can prove, that is very important theorem of the normal subgroup, and this question asks in university examination 7 marks question. That is very important. So first we draw the Cayley table. Now what is the Cayley table? Now Cayley table, A B C D, A B C D. Now A B C D, A B C D, B C D A, C D A, B. That is very simple. Here is a binary operation. That is very simple to draw the Cayley table. Now let G is A B C D and let H is also A B C D, and we can say that H is a subset of B here. Now if G is a group, here is G is a group already given. We can check the every property of the group. That is, first one is a closure, associative, identity and inverse. What is the identity? Identity element is known as the A here in this problem. Now if we operate any element of A, H, A inverse, that we prove the H. Now what is the it means any element and the inverse of that element we operate with H, then we find the H, then that theorem are proof. Now what is the inverse of B? Now inverse of B is D. What is the inverse of C? Inverse of C is C, and what is the inverse of D? Inverse of D is B. It means B operate D if we find the H, then that theorem are proof. It means B, A, B, C, D and operate D. If this is H, then that theorem are proof. It means if we operate B operate A, that is B, B operate B, that is C, B operate C, that is D, and B operate D, that is A. And that is the one element and that is the inverse of that element. If it is H, then theorem are proved. D operate B, D operate B, that is A. Now D operate C, D operate C, that is B. D operate D, D operate D, that is C, and now D operate A, that is D. Now this theorem are proved. Here is H now, and we operate that element and that inverse element, and we prove the H. Now this is a very important theorem, asked many times in the university examination. That is very simple, we prove using the Cayley table. Move to the next property of the group, that is very also important property, so that every cyclic group is abelian group. Now what is the abelian group and what is the cyclic group? First we discuss, then we are going to prove. Now abelian group, that is very simple. If A into B, B into A, any mathematical structure for any two number, then that group, that mathematical structure is known as the abelian group, including all the property of the group. Then we can say that that mathematical structure is known as the, add one extra property, that is commutative law, with the property of the group, then that group is known as the abelian group. Now what is the cyclic group? That is very simple. Cyclic group, if in a mathematical structure contain at least one generator element, then that a group is known as the cyclic group. What is the generator element? A to power n and generate all the elements of the group, then A is known as the generator element. If at least one element contained in a group, then that group is known as the generator element. Now cyclic group and abelian group is clear. Now we move on the theorem. Every cyclic group is known as the abelian group. Now what is the abelian group? Abelian group simply A into B, and we are going to prove A into B is equal to B into A. Now we taking the property of the cyclic group. If A is an element, then it can be generate any generator element, that is A to power n. If B is an the element of the group, then it is also generate by A with different power. That is very simple. And using the mathematical concept, we can write this one. That is very simple. And we can also write this one. That is very simple. Now we can write what is A to power m and A to power n, and A to power m is known as the B and B to power n is known as the A. it means A into B is equal to B into A, or this property is known as the abelian property, or this one is the cyclic group. It means every cyclic group is abelian group. Now, this is the 4-line proof of this question, is also a most important question. And we move from the another property, another question of the group theory. This is also the very most important question which is asked in university examination. Now, D36 with operation division, that is a lattice. Now, what is the approach to solve such kind of the problem? First, we find the D. Now, D is 1, 2, 3, and next element is 4. Are contained or not? So, 4, yes, 4 is contained. 5, 6, 6 are contained. 7 not contained. 8 not. 9, then 18, then 36. So, these are the structure, these are the mathematical set contained in this set. Now, we draw the hash diagram of using this structure, and then we check join and meet for every 2 pair of the element. If contained, then that structure is known as the lattice. Now, first we draw the 1, then here is a 2, 1 connected to, here is a 3, now next one is a 4, now here is a 4, and 4 is also connected to 2. Now, next element is 6, now here is a 6, sorry, here is a 6, and 6 are related to 2 and 3. Next element is 9. 9, yes, 9 is here, I think, and 9 is related to 3 only. Next element is 18. 18 is here, some about here 18, and 18 is related to 19 and 6. Yes, and next element is final element, that is 36 is here. Now, 36 is related to 6 and 18 and 4 also. Now, yes, no, yes, yes. Now, this one. Now, this one is the structure hash diagram of this given structure using the division operation. Now, for every 2 element, if join and meet are contained, then that structure is known as the lattice. Now, for every 2 element, we taking randomly for 3 and 6. What is the join? And 3, 6, and 3. Now, this is the known as the join. Now, this is known as the meet. This is the symbol of the join, this is the symbol of the meet. Now, 3, 6 here, the first time meet on the top, that is known as the join. First time meet on the bottom, that is known as the meet. Now, 3 and 6, first time meet on 36. First time meet, I think 18, here is a 18, and first time meet on, that is 1. It means for every 2 pair of the element, there should be contained join and meet, so that this structure is known as the lattice. We take another 2 pair of the element, for example 9 and 4. We find the join and meet for these 2 random element. Now, 4 join 9 and 4 meet 9. that is join, and that is meet. Now 4 and 9 first time meet on 36, and 4 and 9 first time meet 1. Now this connection is, I think 3 and 4 are not connected. Now here this side, this is not, because 2 is 4, yes, 3 is 6, now it is okay. So now 4 and 9 the first time meet on the bottom, that is 1, and 4 and 9 first time meet on the top, that is 36. It means for the these two pair of the element, that should be contained join and meet. So that I think 2 and 4 element are tested, then we can say that this structure is known as the lattice. Thank you, student. We meet some more interesting problem in next lecture.